Hello and welcome. I hope you're having a great day. My name is Chanu Damarla, and I'm the Principal Product Manager for AWS Lake Formation. Along with me is Mert Hokanen. He's the Principal Big Data Architect for AWS Lake Formation. And in this session, we'll talk about data lakes and how Lake Formation helps you secure and govern your data lakes easily. We will start with an overview of why our customers are building data lakes. Then we'll review some of the challenges with building data lakes, introduce lake formation and how lake formation solves for those challenges, and then we'll really do a deep dive into the lake formation security model, the topic of this webinar. And finally, we'll end with a short conclusion. Let's dive right in and talk about why customers are building data lakes. The simple answer is that customers are building data lakes because they want more value from their data. The data volumes they're managing are growing exponentially, from terabytes to petabytes, and in some cases, even exabytes of data. In addition, they're increasingly working with diverse data sets like logs, real-time streams from IoT devices, voice recordings from their call centers, or videos from a social media site. And finally, we're seeing that data is being used not just by more people in an organization, but increasingly by applications to automatically take action when conditions change. For example, an application may automatically order new supplies when inventory in a store drops below a certain threshold. Traditional on-premises solutions aren't able to handle these data volumes because they don't scale well enough and often are too expensive. To handle the increasing volumes and diversity of data and make this data available across their organizations, increasingly, we're seeing customers building modern data architectures to break down data silos. To do this, many companies are taking all the data in their various silos and aggregating it in data lakes to enable analytics and machine learning applications. They're also leveraging purpose-built data stores like data warehouses to quickly get results for complex queries on structured data, or in a search service to quickly search and analyze log data, for example, to monitor the health of production systems. These modern data architectures are built around scalable and secure data lakes. Data lakes are the new information hub. They're a flexible, secure repository that enables you to govern, discover, share, and analyze structured and unstructured data at any scale using the tool of your choice. Our customers appreciate the flexibility that data lakes provide. By keeping their data in open formats and using standards-based applications, our customers are always able to ensure that their users are able to use the right tool for the job. These tools process data in place, so you don't have to move data into and out of every single engine that you want to use. You're not building another walled garden that you need to migrate data into and out of. You can simply work with the data in place using the tool of your choice. It's important to remember that customers build data lakes to break down data silos. And so data lake is not the new monolith. In fact, our most advanced customers often have multiple data lakes in multiple accounts across their organization. They understand that their architecture has to reflect the realities of how data is generated, processed, and shared across their organization, and in some cases, even across organizations, like with a vendor or a customer. And these customers are building data mesh architectures that enable the governed sharing of data products across one or more data lakes. For example, the web team in your organization may be responsible for processing log data and to make curated data sets available that they then share with other lines of businesses in your organization, like marketing or engineering. And these lines of businesses may create and share curated data sets of their own. Now, of course, all of this sharing has to be governed in order to ensure that your organization complies with applicable regulations. There are more data lakes, data meshes, and analytics on AWS than anywhere else. In fact, we have hundreds of thousands of data lakes on AWS. Now, despite the popularity of data lakes, there are several challenges with building and securing data lakes. And I'll briefly review what those are now. In working backwards with our customers, we identified 5 key challenges that they worked through as they were building their data lakes. And these challenges are, first, building reliable data ingestion pipelines can be complex. Second, managing how data is stored and optimized in S3, their data lake store, can be time-consuming. Third, managing fine-grained permissions at scale is difficult and error-prone. Fourth, sharing data across accounts and across your organizations can be cumbersome. And fifth, securely integrating the service or application of your choice into your data lake architecture can be hard, and in some cases, even impossible. In this webinar, we're going to dig in to challenge number 3 and challenge number 4. How do you secure and govern your data lake? And how do you share the data inside your data lake across your entire organization? But needless to say, because of these challenges, building and securing data lakes can still take months. And that's why we built Lake Formation. Lake Formation is our fully managed service to help you build data lakes quickly. It simplifies security management with centrally defined security, governance, and audit policies. And finally, it provides self-service access to data so users are able to get the most out of the data in your organization. Since launch, Lake Formation has seen rapid adoption and is now used with thousands of customers who are managing petabytes of data using Lake Formation. These customers chose Lake Formation because Lake Formation helps them resolve some of the key challenges with building, securing, and managing data lakes. Now let's dig into the topic of this webinar, the Lake Formation security model. Like I said, we're going to be talking about the security and governance capabilities of Lake Formation, as well as how Lake Formation simplifies sharing data across your organization. Now, before we can talk about the Lake Formation security model, it's important to motivate what we're doing. And so let's talk about first why managing data lake permissions is hard. The first reason why managing data lake permissions at scale is difficult is because when you build a data lake, what you're really doing is you're disaggregating the traditional components of a database by splitting up storage and putting it into something like S3, by splitting up the metadata and putting it to a data catalog like the Glue data catalog, and splitting up the compute by putting it into an analytic engine of your choice, like Athena or Glue, EMR, Retrospectrum, and so forth. Now, when you do that, what's happening is that each of these systems has different permissions, and you need to manage those permissions individually. For example, to manage permissions to S3, you may be writing resource policies. To manage permissions to the data catalog, you're managing IAM policies. And to manage permissions in an analytic engine, you're configuring the analytic engine to work with the data catalog and then managing IAM permissions for your users to access this engine. Keeping all of these permissions in sync as you add new resources and new users can be difficult. As a result, what we find is sometimes customers are actually configuring overly permissive data catalog policies or overly permissive S3 policies, and this can be a no-no. The second reason that managing data lake permissions is difficult is that you need to be able to configure fine-grained permissions to restrict access to users. Remember, we built a data lake to house all your data, and now you have to make sure that individual users only have access to the portions of this data that they're supposed to have access to. So we need fine-grained permissions that restrict what an individual user can see. Now, it may be possible to manage if you have a small number of resources or users, but with data lakes, you're typically talking about thousands of databases and tables going into tens of thousands and tens of thousands of users, sometimes even going into the hundreds of thousands of users. So managing permissions at scale can be a challenge. And the third reason that managing data lake permissions is difficult is that on the one hand, by building data lakes, we're really trying to democratize access to data in your organization. And on the other hand, you have to ensure that this access complies with your regulatory and governance requirements. You need to be able to monitor and audit data access across the entire data lake stack. But where do you look? Do you audit metadata access in the data catalog, or do you audit your S3 access logs? How do you stitch the trail from a query in Athena leading to a set of metadata access calls on your Glue data catalog, which in turn led to a series of S3 reads? Simplifying data lake permissions management at scale is one of the core capabilities of Lake Formation. Lake Formation simplifies data lake permissions management by introducing database-style fine-grained permissions on data catalog resources. These permissions apply across the data lake stack. This means that Lake Formation manages access to S3 buckets and objects where the data associated with the data catalog resources actually resides. These permissions also work with a wide variety of analytics and ML engines. To scale managing permissions, Lake Formation provides Lake Formation tag-based access control, or LF-TBAC. And finally, because all access is happening via Lake Formation, authorization to metadata, and authorization to access S3, it is easy to monitor and audit data lake access to verify compliance with your policies. We'll dig into each of these items in a bit, but first, I often get asked the question, how do IAM and Lake Formation permissions work? Like, what's the relationship between them? Basically, what Lake Formation permissions are is a new authorization layer on data catalog resources. We first started off with just IAM permissions, and then we added another authorization layer. So just like there's IAM authorization, we now have Lake Formation authorization as well. So IAM and Lake Formation permissions are always working together to authorize access to the Glue data catalog. But we don't expect you to copy or keep the IAM policies and the Lake Formation policies in sync all the time. And so the recommended usage is for you to use IAM to define coarse-grained access to your data lake resources, and to use Lake Formation to define fine-grained access to your data catalog resources. Now, let's dig into the Lake Formation permission model. First, Lake Formation permissions support a database-style grant and revoke permissions on data catalog resources. Lake Formation permissions confer capabilities to principals on resources. Principals can be IAM users, IAM roles, SAML users, or SAML groups. This means that you can give IAM users, IAM roles, SAML users, and SAML groups access to resources. Resources are data catalog resources, like databases within the catalog, tables within the database, and so forth. And this is the key part. You can split up tables into columns, rows, or cells, and a combination, or even a combination of rows and cells. And we'll talk about that in a little bit. The permissions available are based on the resource. So for example, on tables, you can grant principals metadata permissions to describe the table, alter the table, or drop the table. And maybe more relevant, you have data permissions, so you can insert data into the table, delete data from the table, or select data from the table. Now, Lake Formation does support delegated permissions management, and you can do that using the grantable option. So when you grant permissions to a principal, you can grant those permissions with the grantable option. And so if you give a user permissions with the grantable option, what that means is that the user then will be able to grant the same permissions to other users. So the use case here is that you nominate someone as the administrator and you give them access to a set of resources with the grantable option. And then that administrator will then be able to further grant permissions to the rest of the users inside his or her organization. And a final point about Lake Formation permissions is that they are additive. And this means that the effective permissions for a given user is the union of all the grants that have been given to that user. Working with the permissions model should be natural to anyone familiar with database permissions. Lake Formation also supports fine-grained permissions. Let's dig into that. Now, since launch, we always supported the ability to grant access at the column level. You could do this by specifying an include list, which says, hey, give access to these specific columns to a given user, or by specifying an exclude list. So you grant access to all the columns except the exclude list columns. And so the use case there is that you could basically say, hey, grant Chanu access to all the columns in the table except the columns that contain personally identifiable information, like social security numbers or date of births. Now at reInvent this year, we announced the general availability of Lake Formation row and cell-based permissions with initial support in Glue, Athena, and Redshift Spectrum. With row-based permissions, you can grant access to specific rows in a table. This can be used, for example, to give each hospital administrator access to patient data in their region. To set up row-based permissions, you specify a row filter using a PartiQL expression. So for example, where region equals New York City. And cell level permissions combine column and row filters to further restrict access to data. This may be used, for example, to give hospital administrators access to patient data in their region, which restricts access to things while restricting access to things like personally identifiable information, like date of birth or social security numbers. To use row or cell level permissions, you create data filters. Now, and we'll talk about how to create data filters during the demo. Now, I mentioned before the Lake Formation permissions work across the data lake stack, and you can manage access to S3 buckets and objects where the data associated with data catalog resources actually resides. Lake Formation does this via a technique called credential bending. So you no longer need to manage and keep data catalog and S3 permissions in sync. You can use or register data locations with Lake Formation and then define permissions on catalog resources. And then Lake Formation will vend or give temporary credentials to analytic engines so they can access S3 on behalf of users. Let's take a look at a sample query to see how this all fits together. A data lake administrator sets up permissions in Lake Formation and registers the location where the data assets reside with Lake Formation. Now, when a user submits a query via an integrated service like Athena, Athena will first ask Lake Formation to verify that the user has permissions to access the tables in the query. If the user does have access, then Lake Formation will return temporary credentials so Athena can access S3 on behalf of the user. Then Athena will access the data on behalf of the user, execute the query, filter the results by enforcing lake formation permissions, and returning the filtered data back to the end user. Now that we reviewed how lake formation permissions work, let's take a look at how you can set them up. And to do this, I would now like to hand it over to Mert Hokanen, who will walk through the demonstration.
Thank you, Chanu. The demos in this webinar will use the NYC taxi trip dataset. This is a public dataset available freely on AWS. We have already copied this data into our account, and the data is organized in an Apache Hive style table. We have 3 partition columns: taxi type, which denotes if it's a yellow or green taxi cab, and the year and month in which a fare was taken. At the bottom, we show how the data is laid out in S3, and on the right-hand side, we show some of the columns within the table. In the first demo, we're going to show how we can permission different personas using different permission sets. For the first persona that we're going to permission, we're going to look at the data engineer. The data engineer typically owns and manages data sets, and we're going to permission this data engineer access to the entire table. The second persona we're going to look at is a data analyst. The data analyst will consume this data, but we may have some sensitive data that we do not want this data analyst to see, and therefore we're going to restrict certain columns from the table from this data analyst. Finally, we have a yellow cab data analyst. This is a persona that we may want to restrict only yellow cab data for this particular persona. So let's get into it. So we have here the Lake Formation console. So in the first scenario that I mentioned was giving the data engineer full access to our NYC taxi data set. To do that is quite simple. We go into our database, NYC taxi, and our data set is NYC taxi fares. We'll go to action, grant. We'll select our principal, which is our data engineer. The database is NYC taxi, the table is NYC taxi fares, and we're going to give him full table permissions. Under data permissions, we're going to grant him access to all data access and grant. Now within my browser, I have 3 different colored tabs. The first tab is a data engineer, and this is Athena. So now if I do a refresh within Athena, I will see my the database and the table that was shared with him. So the next persona is going to be the taxi analyst. So let's go back to our databases, view our tables, go back to our table, and go grant. This time, we're going to select our taxi analyst. Same database, same table. This time, we're going to give him select permission, but instead of all data access, we're going to go column-based access. Now, I mentioned there may be some sensitive columns in this table, so we're going to exclude some columns, and we're going to exclude the vendor ID, the location IDs as well, the pickup and drop off. And then we do a grant. Now, if we go and refresh the NYC taxi analyst, the table is there. And if we expand it, we see that the location and the vendor ID columns are no longer there. Additionally, if we go ahead and query this table, the results also don't have those columns. Now, the last persona that we're going to grant permissions to is the yellow cab analyst. With this analyst, we're going to restrict actual rows that this persona can see. So we'll go through the same grant screen, go to select the yellow cab analyst, same database, same table, but this time we're going to use a data filter. Now we don't have any existing data filters right now, so we're going to create one. So we're going to name our data filter similar to the taxi analyst. We're going to exclude our sensitive columns, so the vendor ID, pickup location, drop-off location, and our expression, we're going to put in taxi type equals yellow. We create a filter, and then now we select our filter. In this case, we want them to be able to select from this filter and then be grant. Now, if we go over to the yellow cab analyst, do a refresh, this analyst has access to the table. They don't have the sensitive columns. And this time, if we query this table, you'll see that the only rows that come back are yellow taxi types. So I hope this gives you a good overview of the different ways to permission using named resources. Back to you, Chanu.
Thank you, Mert. Now, if you had to manage these permissions on hundreds or thousands of resources the way Mert just did, it would become tedious quickly. And so to simplify managing lake formation permissions at scale, Lake Formation supports Lake Formation Tag-Based Access Control, or LF-TBAC. Using LF tags to manage permissions is pretty easy. First, you define your LF tags and the values those tags can take. You can also specify who can annotate resources with specific tags and values. Then you assign your lake formation tags to resources. You can add lake formation tags to databases, tables, and columns, and lake formation tags are hierarchical. This means that when you annotate a database with a specific lake formation tag, all the tables within that database will inherit this tag. Now, of course, it's possible to override these inherited tags. So if you tag a table, then all the columns in that table will inherit this tag. And you can override the tag value for a specific column as well. Once you've created your lake formation tags and annotated your dataset resources or data catalog resources with those tags, you can simply create or define policies on tags to scale permissions management. And setting up permissions based on tags is similar to setting up permissions on resources. And now I will turn it over to Mert.
Thank you, Chanu. For this part of the demo, we're going to demo Lake Formation tag-based access control. We're going to go through 4 different steps. The first step is we're going to define our Lake Formation tag ontology. We're going to create a data sensitivity tag and a line of business tag and tag different resources using those tags. The next step is we're going to be associating Lake Formation tags with our resources, basically meaning we're going to be tagging the resources with the tags that we just created. The third step is we're going to grant permissions based on the Lake Formation tags themselves, and then have the personas be able to access the resources that are now tagged. Lastly, we're going to manage permissions of Lake Formation tags by allowing the taxi data engineer to be able to describe and associate these tags so that the data engineer can now tag resources that are under her control. So we're back into the Lake Formation console. Now, under permissions, we have 2 different sections to manage Lake Formation tags. Shows us the current Lake Formation tags that we've created and their definitions. We already have one for department, and within this tag, we have 3 unique values: New York subway, New York City public bus, and New York City taxi. We're going to create a new one to denote the sensitivity of certain data sets. So we'll go ahead and add a lake formation tag. We're going to call it confidentiality. And we're going to give it 3 different values: private, sensitive, and public. Great. So now let's go back to our databases and then let's start tagging our resources. So the first thing, we have our New York City taxi. We're going to go ahead and edit the lake formation tags for this database. And this has already been tagged with the NYC value with the department tag. And we're going to make this confidentiality public so that everyone who has access to the public tag with the NYC value will be able to gain permissions to this database. Let's go to our tables because we do have some sensitive data. We'll drill into, go to the schema. And one thing you'll notice is that each of the columns have 2 lake formation tags. That's because it has inherited the tables tags and the databases tags. So we'll go ahead and select the vendor ID, the pickup locations, click on edit tag, public, and we're going to change this to sensitive. And we'll save the new version. Awesome. So the third step was granting permissions. So we'll go down to our data lake permissions, grant. For our data engineer, we're going to select resources matched by lake formation tags, and we're going to build an expression. So for this, for the data engineer, we're going to give them permission for the New York City taxi, and we're going to give them complete permission to be able to create tables, drop tables, describe, and same with the table permissions. Now, anything that is tagged with the NYC taxi tag will now be visible for this persona. So if we go back to our data engineer, do a refresh, we'll notice that the 2 additional tables that inherited from the database, we can now see for the data engineer. Now we're going to grant permissions to the taxi analyst, and we're going to build our expression. So we want them to be able to access anything from the NYC line of business, but we're also going to add confidentiality for public. So now our expression is anything where department equals NYC taxi and confidentiality equals public. I want this user to be able to describe any databases and then select and describe any tables. Now, if we return to the NYC taxi analyst and do refresh, they will also get the 3 tables. But again, if we expand the NYC fares, they still don't see the sensitive columns. The last step is to be able to delegate the association of lake formation tags to different principals within my account. Because I am right now logged in as a lake formation admin, I have full authority to be able to create, describe, and tag any resources that I see within my catalog. But we may want to delegate this to a different persona. In this case, we're going to delegate tagging permissions to our data engineer so that they can tag and change the tag values they deem necessary for their data sets. So in order to do this, we're going to go and click on the lake formation tag permissions. We're going to grant, select our data engineer, select confidentiality. We want them to be able to tag using the public and sensitive, and department only the NYC taxi tag. For them, we would like them to describe and associate the tag, grant. Now the data engineer can go to the data sets that they manage and be able to change the tags and the confidentiality based on the data's needs. Thank you. Back to you, Chanu.
Thank you, Mert. And now we'll get to the last portion of our webinar, which is sharing data across accounts. And again, like before we talk about sort of how Lake Formation does it, let's understand what's hard about sharing data across accounts. And so previously, to share data across accounts, you had to set up cross-account IAM and S3 sharing policies. These policies had limited service support. But perhaps what was even more problematic is that they lacked discoverability. You are setting up these policies in the producer account. So from the perspective of a consumer where you actually want to access the data, you actually didn't have an easy way to figure out what data sets you had access to. And finally, because of policy size limits and restrictions, um, there were some restrictions on how you could share data. And so often or sometimes we saw our customers using coarse grain sharing. Now, if you didn't want to manage cross-account S3 and IAM policies, then you had to create multiple redacted copies of your data set and then copy these data sets into the consumer account. This required ETL pipelines that were expensive, brittle, and error-prone. Lake Formation simplifies cross-account sharing. And we did this by extending the permissions model to enable the sharing data across accounts. Producers grant permissions to consumer accounts. And in the background, Lake Formation will share the data catalog resources with the consumer account, and these shared resources will now be visible in the consumer account's data catalog. If the producer used the grantable option when granting these permissions, the consumer's data lake administrator will be able to further grant permissions to other users in the consumer account. The consumer then creates resource links to share to the shared resources, which are then used by analytic engines. The best part is, from an analytic engine's perspective, accessing a resource link is the same as accessing a regular data catalog resource. And Lake Formation seamlessly proxies API calls on resource links to the producer account to get the latest up-to-date information for calls like get table or get partitions. And sharing data across accounts is simple, and we'll hand it over to Mert, who's going to talk through how to share data across accounts.
Thank you, Chanu. Within this demo, we're going to show how we can share data sets across different AWS accounts. Suppose that the NYC taxi department has their own AWS account, and we're collecting data on their behalf. And we want to share the NYC database with that account so that they can consume it. In this demo, we're going to show how easy that could be. So let's get into it. We're going to share our data sets using Lake Formation tags, although we could have used named resources as well. The process is very similar to sharing to an individual principal. So let's see how this works. So within the Lake Formation console, we're going to go to grant. We're going to, instead of doing IAM users and roles within this current account, we're going to select external accounts. And then we put in the account ID here. If we were a part of an AWS organization, all the AWS organizations would show up in the dropdown, and you can share in that way as well. But for now, we're just going to share with our other account. Similar to how we provided permissions to the New York analyst, we're going to share using Lake Formation tags. So here, we're going to share anything that is tagged public and the department being NYC taxing. That way, any resources that are tagged with both of these tags with these values will be shared with the account. Under database permissions, we're going to give describe permissions and grantable describe. The grantable permissions is important as it allows the Lake Formation admins in the shared account to be able to grant permissions on this resource. For table permissions, we're going to select both for the table permissions and grantable permissions. And we go ahead and grant. Now, if we go into our other account, the consuming account, if we do a refresh within the Lake Formation console, we should now see the database. And we also see that it's coming from our original account. So in order to make this shared database visible to the users within this account, we need to create a resource link. This shared resource does not exist within my catalog, so we need to make it visible. And we do this by going and clicking on Actions, Create Resource Link. We can name this resource link anything we want, but we will keep the same name. And now this resource link exists within my local catalog. Now, in order to permission a user within this account, we're going to need to grant two permissions. So first, we're going to grant a permission on the resource link. So in this account, we have an analyst role. Next, we're going to give that user describe permissions on the resource link. Great. Now, the user can now see the resource link, but we need to also grant permissions to the underlying resource. So we do that by view tables, go to the NYC taxi fares table, and grant. In this case, we're going to grant to the analyst, the database and table. We can add a filter if we wanted to, but we're going to forego that right now. We're going to select an all data access as well. And we're going to grant. Now, if we go into Athena as the analyst role, we do a refresh. We now see that the database, the table, and you'll also see that the sensitive columns are also not here, as that is managed by the Lake Formation tag. And I can now query the table. So with a few simple steps, we were able to share a data set from our producer to our consumer and permissioned a user to be able to read that data. Thank you very much. Back to you, Chanu.
Thank you again, Mert. Using the cross-account data sharing capabilities of Lake Formation, our customers have set up many different sharing topologies, from centralized hub and spoke models to sharing data with their across their organization, as well as with external companies like vendors, suppliers, aggregators, and distributors. And increasingly, they're building data mesh architectures using Lake Formation cross-account sharing. We've spoken a lot about the Lake Formation security model, but let's talk about I just want to highlight some customer use cases. Customers like Macromill, a leading market research company in Japan, and FanDuel, an online gaming site, are using Lake Formation to secure the highly confidential and personally identifiable data in their data lakes easily. And they report, they appreciate how they can quickly control access to sensitive and personally identifiable data. And customers like GoDaddy and D2C and NTT Docomo Company are using Lake Formation to share data across their organizations. So in this webinar, we dove into the Lake Formation security model and showed you how you could use fine-grained access control to restrict access to portions of the data lake so your users only had access to the specific parts of the data that they were supposed to have access to. We showed you how to use Lake Formation TBAC to scale the data permissions inside your data lake. And we talked about how you could easily share data across your organization using Lake Formation's cross-account data sharing capabilities. With Lake Formation, it really is simple to build a secure data lake in a matter of days. Thank you. And now we're happy to answer any questions you may have.